Okay, so I'm going to start recording. This section shouldn't take too long anyways, but we want to talk about stoichiometry. And so for this, you can, if we look at the thing we had before, we can go from grams of whatever that is, A, to moles of A, to molecules. Let's say, well, I could use particles again, molecules of A, or back, right? And grams to moles is using the molar mass, like we saw before, and going between particles or molecules to moles or moles to particles is using Avogadro's number. We can also find components, other components in a chemical reaction, moles of B. And from moles of B, I can go to grams of B or to particles of B using the same types of conversions. And this, so this is what we've done before, right? Is we've done this mole conversions, and also from before, we've done that. This bridge going from moles of A to moles of B, this is new. This is actually what they refer to as the mole ratio. Let's use an example. If I have, well, let's say if I have, well, it's 2 nitrogen plus 3 hydrogen goes to, whoops, it's 1 nitrogen. Oh, darn it. Secretly a 1 there. Okay, goes to 2 ammonia. And so in this relationship, I can look at molecules, just like we did before. So this equation, this balanced equation says 1 molecule of nitrogen reacts with 3 molecules of hydrogen to make 2 molecules of ammonia. Would you agree? Is my, oh, is the paper, okay. Oh, you want this part here? I'm sorry, there, okay. Anywho, so let me bring it up just a little bit. We can also go, what if we had 100 molecules of nitrogen? How many hydrogen would react with it? I would say
300.
300. It's exactly right. And I would expect 200 ammonia to form correctly. Okay, I'm going to push this up now. I hope you got your notes. What if we use dozens? I'm going to use a bulk number. 1 dozen ammonia. How many hydrogen will react? I would say 3 dozen. How many ammonia will form? I would say 2 dozen. Finally, let's use a different bulk number, kind of like what we did last time. Good, someone said 2 dozen. Moles. So 1 mole of nitrogen, yeah, will react with how much hydrogen? You guys seeing this? 3 moles.
3 moles of hydrogen, and that will produce 2 moles of NH3.
That's perfectly correct. Very good. And so these are ratios. These are what I call mole ratios. So I can write them as a fraction if I want. They're all equal to each other. And I can have 1 mole of nitrogen over 3 moles of hydrogen. Or I could have 3 moles of hydrogen over 1 mole of nitrogen. If I wanted to cancel nitrogen, I'd use this one. If I wanted to cancel hydrogen and find nitrogen, I'd use that one. Or 2 moles of NH3 over, there's actually 6 different conversion factors. 2 moles of NH3 over 3 moles of hydrogen. And this one could be flipped over. Excuse me. Or 2 moles of ammonia over 1 mole of nitrogen. And this one could be flipped over. So this is actually a very simple reaction, but it has many different quantities. How many sig figs are in these? Anybody on the number of sig figs? I would say infinity. These are counting operations. Yes, infinite, exactly. Someone got it. Okay, good. So that's that. So that's the conversion for that. So if we look back up here, I can do mole mass conversions over here to find moles of something, and then I can use moles of that to find moles of something else. And then once I have moles of that, then I can use mole mass conversions to find the amount that I want of that. And that's essentially the procedure. Let me write it out. So stoichiometry steps. So 1, use mole mass particle conversions to find moles of the known. That's the one they gave you information about. And this is review technically. That's a review situation. And 2, well, once we found moles of the known, use moles of the known to find moles of the unknown. And this is using the new thing, the mole ratio. Technically, there's a step 0. Is it okay? I guess I should have made room. Is it okay if I'm going to put a step 0 up here. Step 0 is you need to have a balanced equation. If you don't have a balanced equation, then you can't do this. Yeah? Okay. And then finally, once you have moles of the unknown, use mole mass particle conversions to find quantity of the unknown. And this is also, this third step is also review. Right? We did this earlier, going between particles of methane. We did this part earlier, going backwards, particles of methane. But this is the new thing. So before we do that, let's do just step 2. That might happen. So if we have, let's use the same equation. I still need the balanced equation. Nitrogen plus 3 hydrogen goes to 2 ammonia, right? If I have 10.5 moles of nitrogen, how many moles of NH3 will form? Can we do that? So I'm going to take this. This is my given. 10.5 moles of nitrogen. And then what's my mole ratio between nitrogen and ammonia? Oh, someone was saying, I wonder how you know you have a balanced equation.
You have to do like a side-to-side check and tally up the total amount of the, say, N molecules on one side and the total molecules of it, and on the other
Yeah,
side, and make sure that they're
I'll,
the same.
I'll, I'll do a balancing in a sec if you guys want. I mean, we can do everything, but, and someone else asked also, can you do this without a balanced equation? And the answer is no. So you must be balanced. If it's not balanced, then you're automatically going to have a wrong answer. Sorry, you're automatically going to have a wrong answer. Okay, so this one is balanced. We could check it. But let's just, well, okay, there's 2 nitrogens here, there's 2 nitrogens there, there's 6 hydrogens there, there's 2 times 3, there's 6 hydrogens there. This one's nice. We could do some more balancing later, but this one's quick to check. Okay, so let's continue. So I have moles of nitrogen. I want moles of nitrogen. What is the mole ratio? Since I have a balanced equation. A mole ratio, let me put that back here. If you guys wrote this in your notes, the mole ratio comes from the coefficients in the balanced equation, right? So what are the coefficients here? That's my answer. What are the coefficients between nitrogen and ammonia? I see secretly there's a 1 here. There's also a 2. So do I want to multiply by 2 or divide by 2? Which one do I want to do? It looks like I want nitrogen on the bottom. 1 mole to cancel. 1 mole of nitrogen, 2 moles of NH3. So then moles of nitrogen cancel. This is 3 sig figs. This is infinity. So I should have 3 sig figs. And I think I can do this one in my head. I think it becomes 21.0. So I got to add that extra 0 to have 3 sig figs. So 10.5 moles of nitrogen will react to make 21.0 moles of ammonia. All right, so that's just balancing. We could do another one of those if you would like. Okay, let's do one more. What about, okay, if 10.5 moles of nitrogen reacted, how many moles? And by the way, the known doesn't have to be a reactant. I could have given you an amount of a product. I could have said, if you have this much product, how much reactant will you need? You can go any which way in here. Maybe we should do one of those. Let's change this. Can I change? Is it okay if I change this? I'm going to change it. If 10.5 moles of ammonia formed, comma, how many moles of hydrogen reacted? So it's the same kind of situation. I'm going to start with my moles of hydrogen. And then I'm going to go back and look at what's my mole ratio between hydrogen. Oh, wait a minute. No, I'm not starting with hydrogen. I'm starting with moles of ammonia. Excuse me. 10.5 moles of ammonia formed. How many moles of hydrogen reacted? So my product is actually my known, and my hydrogen's my unknown. So 10.5 moles of ammonia is my known. The mole ratio is 2 to 3. I want 2 moles of ammonia to cancel and 3 moles of hydrogen to form. I'll need a calculator for that. It's still 3 sig figs times infinity, counting operation. Oops. And I get, well, this is about 1/2. So 15-ish sounds like a reasonable answer. I get 15.75, but I'm going to round it to 3 sig figs. So 15.8 moles of hydrogen. Okay, so that's using moles. We could make this more complicated by introducing mass concepts. So if, let's try a different tack. If 78.5 grams of NH3 formed, comma, how many hydrogen molecules reacted? Question mark. So this one may cause me to use that mole subway. Where did it go? Ah, here. Let me push that. There's my balanced equation. And so if I look at this, I'm given grams of my known. And so I'm going to want to go to moles of known, which would be moles of ammonia. And then I'm going to use the mole ratio to go to moles of hydrogen. And then I'll go down to go to particles, right? So let's consider this. So the first step would be find moles of the known, right? So how can I do that? I have 78.5 grams of ammonia. Is it okay if I give you guys the molar mass of ammonia, or do you want to see that calculation also? Nobody said they needed to see the calculation. So I'm going to want grams on the bottom, which is 17.04 grams of ammonia, 1 mole of ammonia. So that's the first step. And then let's check this out. And that looks like, well, to 3 sig figs, that would be 4.60 moles of NH3. Second step, find moles of the unknown. I'm going to use the answer from this one. 4.60 moles of NH3. I'm going to use the unrounded thing in my calculator. It's actually 4.604 stuff. What's the mole ratio? Wait, where's my balanced equation? Come back. Aha! Two moles of ammonia are formed from the reaction of 3 moles of hydrogen. So I want 3 moles of hydrogen on the top, 2 moles of ammonia on the bottom. So times 3 divided by 2, and I get 6, with my unrounded version, I get 6.91 moles of hydrogen. Yeah? Okay. Step 3, find quantity of unknown. So I'm going to use this answer here. 6.91 moles of hydrogen. I'm going to use the unrounded value in my calculator again. I want to find particles. molecules. How can I find molecules? What have I got to do? Let's go back to the, so now I'm here. I want to go from moles of hydrogen to molecules. What will my conversion factor be? I would say that would be Avogadro's number, just like we were doing in the beginning, right? Let's go back to here, times 6.022 times 10 to the 23 hydrogen molecules over 1 mole of hydrogen. So moles of hydrogen cancel. I'm going to take my raw unrounded value in my calculator times 6.022 second 10 to the 23. And I get, well, 4.16 times 10 to the 24 hydrogen molecules. And let me just show, I want to put this all together because we're going to take 78.5 grams of ammonia times 17.04 grams over 1 mole of ammonia, grams cancel, times counting operation, 2 moles of ammonia, 3 moles of hydrogen, moles of ammonia cancel, times 1 mole of hydrogen, 6.022 times 10 to the 23 hydrogens, right? And in that case, moles of hydrogen cancel. And if I look at the sig figs, it's 3, 4, infinity, 4. So my answer had 3. And it should be the same as that. You can check that with yourself. Okay, I want to stop the video here. We could do another example of this if you want, but I'd like to actually try a new concept. Did you guys want to, well, actually, let me ask the peanut gallery first. Do you guys want to see another one of these before I go to another concept? Does anybody need to see another one? Okay, somebody wants to see another one. Okay. I have 7 minutes. Okay. Let's, if 23.8 grams of nitrogen is available, how many grams of hydrogen will I need? And so the next, did I turn off the recording? It's still recording. Let's do this one. Okay, so I'm gonna go from, I'm gonna find, number one, I'm gonna find moles of the known, 23.8 grams of nitrogen. I'm gonna give you the molar mass, which is 28.02 grams of nitrogen, 1 mole. So that's step 1. Find the moles of the known, right? Did anybody need the molar mass calculation? I guess not. Okay. Then I'm going to use the mole ratio, step 2. Find the moles of the unknown. In this case, where's my balanced equation? Oh my gosh. Make sure we have it. Uh-oh. There it is. So now we're looking at nitrogen and hydrogen. It's a 1:3 ratio. So 3 moles of hydrogen are required to react with 1 mole of nitrogen. So now let's cancel some stuff. Grams of nitrogen were gone. Moles of nitrogen are gone. The next step So that was step 2. I found moles of the unknown. Step 3 is find quantity of the unknown. In this case, I don't want molecules, I want grams. So now I'm going to use molar mass. 1 mole of hydrogen, 2.02 grams of hydrogen. So then moles of hydrogen cancel. And then it's a calculator issue. So 23 divided by 28 is a little less than 1, times 3 is a little less than 3 times. So it's a little less than 6. So it's like 4 or 5 grams of hydrogen. Let's find out. Clear. 23.8 divided by 28.02 times 3 times 2.02. Yep, pretty close. I got, and oh, how many sig figs should I have? Does anyone want to figure out the sig figs? It looks like 3 here, 4 there, infinity there, 3 there. So I should have 3. I get 5.15 grams of hydrogen are needed. Okay. So would you guys like to see another, or can we go to another concept? Can I go to another concept? Is that okay if we go to another concept? No one's saying anything. So I want to stop the recording here. If there are any questions,